So, welcome back. Next thing we are going to talk is about how can we conduct these alkylations. So basically, we can try to think it in terms of what are the types of catalysts. So usually the process is very related to the types of catalysts that we use in this process. Usually the catalyst that we are using a sulfuric acid. And the second one, we are using a hydrofluoric acid. So usually, what are the purpose of this catalyst? In general, the functions of the catalyst is to increase the reactions rate, or in other words, it makes the reactions to be occur at less severe conditions. So here I would like to bring up some simple examples. Under the influence of catalyst, the temperature that we use are probably lesser than 50 degrees Celsius. At the meantime, the pressure that we use, they are lesser than 30 bar. So probably now we can have the questions. Is the alkylations can be occur with the presence of catalyst only? No. The answer is no. So even there's no presence of catalyst, but the reactions can be still occur, but under different conditions. So without catalyst, the temperature required is extremely high. It's probably about 500 degrees Celsius. And then what about the pressure? Pressure is up until 200, up until 400 bar. Yes, the temperature and pressure. There's a very excessive high temperature and pressure required for alkylations to occur without any catalyst. So, with the presence of catalyst now, the temperature and pressure is the alkylations can be conducted at much lower temperature and pressure. Then the next thing, probably I'm interested to know about the types of feedstock in this alkylations process. For your information, we have two different feeds that's going to be the raw material for this alkylation process. We need to have isoparaffin. Secondly, we need to have olefin. So, in this case, in these alkylations, usually the isoparaffin that we use could be isobutane. So, in what sources that we can obtain this isobutane? Usually, we can obtain it based on few processes. For your information, the first one, probably I can try to think, is about FCC. Yes, it's about FCC. And then there are some other resources that could be used to produce this isobutane. We can also have hydrocracking. Not forget to mention the next one. The third classes, in my opinion, will be reforming and isomerizations. For olefins, it will be more specific. Usually, we obtain it from using FCC. So do you still remember the functions of a fluid catalytic cracker? In FCC unit, the purpose of this FCC unit is that a large hydrocarbon is being break into two smaller compounds. For instance, a smaller paraffin as well as another olefins. And then, at the meantime, olefins also equally contributed by some other sources, a coking process. Last but not least, actually some of us obtain olefins through dehydrogenations of paraffin. So imagine that here we have a straight chain paraffin. Upon dehydrogenate, probably it will form an olefin, and these olefins could be used in alkylations process. So this is all about the types of feedstock. Usually we have two different feeds into these alkylations. We have isoparaffin and we have olefin. Isoparaffin, for instance, isobutane, can be obtained through FCC and also HC. Most of the sources of saturated hydrocarbon contributed by FCC and also HC. And then sometimes, because this is isoparaffin, so usually we can produce a straight chain paraffin, and this straight chain paraffin will be reformed and isomerized into an isomers of paraffin. Lastly, the olefins. The olefins could be, mostly will be produced through FCC and also coking process. Coking is something like a thermally cracking process. And then, at the meantime, we also can produce the olefins through dehydrogenations of paraffin. Then the next one, we are going to talk about the products form. So, for your information, I would like to highlight two major products. So probably in our notes, we know that actually we have some other products from, let's say, butane liquid, liquid butane, or even a propane. But here, I would like to mention a C5 alkylate, and the next one is about tar. So for your information, usually in this alkylation process, we are going to produce a large hydrocarbon in which this hydrocarbon has improving octane number. And for your information, the hydrocarbon that we produce through alkylations, they are usually falls within gasoline range. So that's why we always have a product of C5 plus alkylate. And the next thing, tar. Tar. We thought that tar is something very sticky or something very high viscosity. Yes, you are right. So basically, tar is a very sticky, viscous liquid. How can we form tar based on these alkylations? So for your information, in our feedstock, we have olefins, isn't it? Actually, the tar is contributed by the polymerizations of olefins. Do you still remember that in chapter 1, we always talking that olefins actually is unsaturated hydrocarbon, and this C-C bond, they are usually very reactive, and hence the olefins, they are usually very easily to form polymerizations, and eventually they are forming tar. So basically, these whole things describing the overall process of alkylations process. So in our next video, we are going to investigate different cases by using a different type of catalyst. We are going to investigate what are the processes involved in alkylations by using hydrofluoric and also sulfuric acid. See you back.